All right, so conditional probability. So conditional probability is just like what it sounds. There are conditions. If you make an agreement with someone under certain conditions, then certain things have to be met before you make that agreement, right? So it's kind of the same thing here. Something has already happened. So what we need to do is we're talking about the probability of an event B, knowing that the event A has already occurred. Okay, so the way we write this, the notation, is like this, and that is read as the probability of B given A. Okay, so it's given that A has already occurred. Now your formula for this is the probability of B given A is we are going to take their intersections, A intersection B, and we're going to divide it by A. So we're just trying to take A out of the picture, and we're just looking at B. All right, so it's a little confusing. I'm going to give you a common sense approach to this, but I'm also going to explain to you how this formula will help you out in other situations. So for number one, Mitchell drew a card from a standard deck of playing cards. There are 52 in them. We talked about that in the previous video. What's the probability that he drew a queen given that the card was red? So first off, the probability that he drew a queen is our B because it's given that the card was red. So that was our A. So A is the probability that it is red. Now, how many red cards are in a deck? Half of them, 26 out of 52. And then the probability that we have a queen, well, there are 4 queens in the deck, 4 out of 52. So our addition or our multiplication rule for and is we'll do 26 over 52 times 4 over 52. That's how we find the intersection of those two. Then we'll divide that by A, which is 26 over 52. Now, some of you may be saying, okay, well, that's really easy. Those cancel out. 4 out of 52 simplifies out to 1/13. That's it. Exactly. Yep, that's exactly what it is. So you may be wondering, why in the world do we need A? Well, sometimes it's a little more confusing, especially once we get to the Venn diagrams, and the intersection really helps you out. Okay, so, but another common sense approach to this is that conditional, let me put it in blue here, conditional decreases your sample size. Okay, so in other words, your total number of possible outcomes. So if you think about this, it's given that the card was red. So how many cards are red? Instead of starting out with 52, let's just start out with 26. We're not looking at the black cards at all. We're just looking for the red ones. And then out of those red ones, what's the probability that you'll get a queen? Well, there's only 2, the queen of hearts and the queen of diamonds. So that will just simplify out to 1/13. And that's a little bit faster than the other method. So if you can think of that and understand and wrap your mind around it, that will be a lot easier for you. But you can always go back and use the method, the formula as well. So for number 2, a number from 1 to 100 is randomly selected. What's the probability that is a perfect square? That's B, given that it's an odd number. So we know it's an odd number, okay? And then out of those odd numbers, what's the probability that it's a perfect square? So perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So that should be 10, right? 1 to 100? Yeah. So our probability that it's an odd number, well, that's just going to be 50 out of 100 because half of them are even and half of them are odd. So that's our A, 50 out of 100. And then we just need the probability that of perfect square. Well, there's 10 perfect squares, so that will be 10 over 100. Those 50s will cancel out. 10 over 100 will give us 1/10. Now you can also look at it another way. You can say, okay, well, given that it's an odd number, so that decreases our sample size automatically to 50. We're not even looking at the odd ones. We're just looking at not looking at the even ones. We're just looking at the odd ones. So now, how many of those perfect squares are odd? So we're going to mark off 4, 16, 36, 64, and 100. And that leaves us with 5. 5 of them are perfect squares, which will be 5 over 50, which still simplifies out to 1/10. Okay, so there are 62 people that take yoga class and 48 people that take spinning class. 15 that take yoga also take spinning. So this is a perfect example of a Venn diagram. There's 15 in the middle. We have yoga and spinning. Now, there's 62 total people that take yoga. So I can't put 62 in this little blank right here. I need to do 62 minus 15, which would actually give me 47. And the same thing on the right side. I can't just put a 48 right here. I need to subtract 48 from 15, and that will be 33. So now you see in the yoga circle, there are 62 people. In the spinning circle, there are 48 people. And then there's 15 in the middle. So what we'll do is we're looking for the intersection of them, and we're dividing it by A, right? So if you know that they take spinning class, find the probability that he or she takes yoga. Okay, so the probability that they take spinning class would be, look at it this way. I'm going to use the common sense approach for the Venn diagrams because I think it's so much easier for you guys. Don't even worry about the other ones. So you know that they take spinning class. Well, how many people take spinning class? 48, right? So then given that they take spinning, what's the probability that they take yoga as well? That would be that middle 15. So then 15 divided by 48 would you can divide those both by 3, 5 over 16. That would be your final answer there. Okay, and the same thing for number 4. So out of these 30 students, 13 are athletes and 9 are in band. Okay, so we got athletes and we got band. 3 of the athletes are also in band. So we have 13 athletes, that would be 10 who are athletes but not in band, and that would be 6 who are band members but are not athletes. Now, if you add those up, 10 plus 3 plus 6, that only gives you 19, right? There are actually 11 other students because there were 30, right? So we have 11 other students. That's like the universal set. Our universal set would be 30 here. There's 11 outside of them. So find the probability that this student is in band if it's known that they're not an athlete. Okay, so how many students are not an athlete? If we just mark out this athlete circle right here, how many are not athletes? We know that that is 17. Okay, so what's the probability that they are in band, given that they're not an athlete? Well, there's 6 of those in band. Okay, so I think that's going to be a lot easier for you guys to keep up with instead of doing the formula, especially when it comes to these Venn diagrams. Okay, so let's see here. A table shows the results of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. So the way we read this is the probability that students prefer football given they are a girl. Okay, so if it's given that they're a girl, that's going to be our sample space. We want to write how many girls there are. So how many girls are there? There are 22. And given that they're a girl, what's the odds that the probability that they prefer football? That will be 6. 6 out of 22, which would be 3 out of 11. Definitely make sure you simplify. All right. What's the probability that they are a boy given they prefer hockey? So how many people prefer hockey? That will be 26. All right. And then the probability that they are a boy would be 10. So 10 out of 26 would be 5 out of 13. All right, so it does help if you kind of add up these totals, these tallies off to the side. So like this one will be 20.